Let us learn about signal conditioning devices ADC and DAC and how to interface them with 8051. An ADC is a device which is used for converting analog signals to digital signals. So usually in certain applications we find that sensors collect data which will be in analog form, but the microcontroller cannot process such type of analog data. Hence we require an ADC which is used for converting the analog data into digital and then it is given to the microcontroller. Generally, an ADC will be having the following pins: SOC, start of conversion; OE, output enable; EOC, end of conversion; digital data inputs, outputs, and analog input. SOC, start of conversion signal, is an input pin of ADC. Usually, once the analog input is applied, a high to low pulse should be given on this particular pin so that ADC is triggered to do the conversion. After the ADC completes the conversion, it gives an output or it gives an indication to the user through the EOC pin, that is end of conversion signal. So we need to monitor this particular pin or receive this signal in order to confirm that ADC has completed the conversion process. Once the EOC signal is received, we have to give the output enable signal to the input pin of ADC. Now this signal has to be given so that the digital data which is being obtained is latched and it can be read from ADC. Let us take a simple example. Write a program to interface an ADC with 8051 and read the digital data from ADC and store it in location 40H. So let us make a note of these pins which is used for interfacing. Port P1.2 is connected to the SOC of ADC. P2.1 is connected to the EOC pin of ADC. P1.4 is connected to the OE pin and port 3 is used for receiving the digital data. So first let us organize the code at 8000H. Let us load the internal memory address to R0. Let us we will assume that the analog input is given and we have to give the SOC pulse. Therefore, set B P1.2, caller delay and clear P1.2. Once the pulse is given, we have to monitor the EOC signal. So let us read port 2 to A and check for P1, P2.1. So move A comma P2, jump on no bit accumulator dot 1 to L1. So this will be continuously executed till there is a bit received, till there is a logic high received in pin P2.1. Once it is received, we have to give the OE signal. So set B P1.4, caller delay, read the data from port 3 to accumulator, loaded it at the location 40H and clear the OE signal. Increment R0 so that the next converted data can be stored in the location 41H and this has to be repeated, so S jump to back. Next is DAC. Certain controlling applications, analog signals are required which the microcontroller cannot give, so we use a DAC. So microcontroller gives the digital signal and the DAC converts it into the analog signal and given for the further devices for its controlling application. The digital data which have to be given for conversion, it is usually provided through the microcontroller port to the digital input of the DAC. So let us take an example. Write a program to generate a sawtooth wave of 4 volt amplitude. So what do we mean by sawtooth waveform? It is your ramp waveform. It has to increase and then it has to come down to 0, again increase and then it has to come down to 0. So this peak value over here is given as 4 volt. Time being, we will not bother about the time difference between these two points. ORG 8000 head, organize it, move 0 to A, output it through port 1, increment A, compare it with CCH. CCH corresponds to 4 volt amplitude. So till it is CCH, this loop goes on executing. Moment it reaches this particular peak, it goes back, brings it down to 0, sends it through the port and again it goes on incrementing. So these are the different devices basically which are used for interfacing with 8051, which is used in designing mechatronic systems. Thank you.